Hello everyone, this is Michael Bagley again, coming at you with some more math and manufacturing. Excited today. Remind you that we're doing what matters for advanced manufacturing, and we're trying to make it where you can see how math and manufacturing come together and the importance of knowing both. Today's example, we're going to be looking at unit conversions, trigonometry, ratios and that dreaded F word, fractions, solving for an unknown, and yet another math F word, there's too many functions. Now the reality, many students I see all the time, including myself, when you see something out of context or just seemingly math for math's sake, it can get really boring and you're like, how does this apply or how does it even work? So let's look at an example that this may seem very unuseful. You have a right triangle, 90-degree angle. This is the Greek letter theta. That tells you the measure of the angle between these two sides over here. One's called an adjacent side, one is a hypotenuse. Trigonometry literally talks about the measure of angles and how they're related to the side lengths. So one thing I always tell my students, and they usually get it, they've heard of the Pythagorean theorem where the longest side is opposite a 90-degree angle. And if you look at it, this is the biggest angle in this triangle, and the bigger the angle, the longer the side that it's opposite. So cool memory thing to see. And there's a lot of formulas that apply to sides of triangles with their angles. One in particular, definition, is the sine function. The sine function is just like any other function. It has an input and it gives you a unique output. You're probably not scared of things like the square root function. You put certain things in a square root, like the square root of 9 is 3. Input is 9, output is 3. Well, sine function, your input is the angle measure right here. And what it's equal to by definition, it's actually a proportion or a ratio or a fraction. It happens to be the length of the side opposite that angle divided by the hypotenuse. And if you look at this, and I'm being real honest, I see my students sad to see, it's like, oh yeah, triangles are everywhere, Dr. B. I really care about this relationship, and I don't blame you for almost getting cynical. Well, that's the beautiful thing about, science, engineering, and manufacturing. You put things together and make it work. So we're going to take this pure math, and let's see how you can actually get something of value. So here we go. Thing of value is you might need to cut a part or cut something at a very specific angle as you're designing and creating something. That has value. So let's look at this. This is another example from a textbook I really like. Mathematics for Machine Technology from Patterson and Smith. And the question says, determine the gauge block height, h, that is required to set a particular angle 24 degrees and 21 minutes with a 5-inch sine bar. So for a pure math person like me, I didn't even realize there was such thing as a sine bar. How cool is that? Now I know why they call it a sine bar, because you're utilizing the idea of the sine function. But a sine bar is going to look something like this, and you're basically going to stack it on top of some blocks at certain heights. And the more blocks, you're going to keep changing the angle, correct? The higher the blocks, the higher the angle. And in particular, we want to cut something at 24 degrees and 21 minutes. Notice the notation. That little circle is degrees, that little first slash is minutes. And it could even go to seconds with 2 slashes if you want to get really accurate. But you have a 5-inch long sine bar. Now all of a sudden, if you look at this carefully, and I'm not sure how well you'll see the color, but if you see this triangle, look at my fingers. I tried to draw it in green. So you have this triangle, all of a sudden now you have a right triangle. And you notice you stack these blocks perfectly vertically so you get a 90-degree angle. You have a hypotenuse of this triangle, but instead of being a boring hypotenuse, guess what it is? It's the length of the sine bar. You have an angle that you need to achieve. You just have to figure out how tall you stack it to this 5-inch sine bar that you're going to use to hit this angle. So if you come over here, the first thing we need to do is your calculator generally is not going to be working with minutes, even though some advanced ones can. I want to show you conversions anyways, because it'll work for you in manufacturing in a lot of cases. So to convert 21 minutes into degrees, you use this thing called a conversion factor. In this case, the conversion factor is there's 1 degree per 60 minutes. You could have flipped this over and had 60 minutes per 1 degree. And students ask me, well, how do you know which way to have it? You always put the unit you want to end up with on top. So I want degrees, I want it to turn it into degrees, so I kept degrees on top and I put the minutes on the bottom. So now it turns into just a multiplication of a fraction. Multiply numerator times numerator, top times top. And do your math, get a calculator out, and you turn this 21 minutes into 0.35 degrees. Now I know that angle, and I can use a calculator with that as my input. So let's look at this. We had sine of theta from earlier, the pure math, was essentially the opposite side, the opposite side, which is the height of the gauge blocks, divided by the hypotenuse, which is the sine bar length. We're trying to figure out what this h is. We know the input to this sine function. We know the length of the sine bar is 5. Now all we have to do is solve for h. Well, when you have fractions, if you remember, when you're solving for a fraction, you can do this thing called cross multiplying. But I tell people, if you don't like fractions, get rid of them by multiplying by the denominators you see. I only see 5 in here, so I'm going to multiply both sides by 5. This side will cancel out and you get h by itself. Then you have 5 times sine of this input. So you go to your calculator. Oh wait, order of operations. Did you watch video Math and Manufacturing Part 2 with PEMDAS? Order of operations. What do I do first? Well, in this case, I'm going to take care of my function. So that's even more advanced. It wasn't even necessarily talked about PEMDAS. But I'm going to put the calculate sine of this input first, and then I'm going to multiply. So in some sense, I look at it as kind of like you're dealing with parentheses over here. So sine of 24.35 degrees, you get your calculator, make sure it's in degree mode. Sometimes people put it in radian mode, in this case, degree mode. And you get 0.412. Accurate enough. In this case, they don't specify how much accuracy they want, so I went 3 decimal spots over. Then you multiply it by 5, and you actually calculate the block height that you would need, about 2.06 inches. You keep adding these thin slices to get a gauge block height to be able to cut at that perfect angle you want. So again, how cool is this? Trigonometry, which seems like it might be a very boring look at triangles and angles, in real life, when you actually need to cut something at a particular angle to achieve the design creation aspect you want. So once again, this is Dr. B. Wanting to make sure you know what math is in manufacturing, and it's good stuff. Don't give up on the math and pursue that manufacturing. So thank you very much.